In this video, we are going to simplify expressions by combining like terms. So in order to explain the general idea behind combining like terms, I'm going to use kind of a real-world example. So here if we read this through, it says, one day a storm hit the zoo and opened every door to the zoo. When the zookeepers returned, they found animals spread out all around the zoo. So near the pond, they found 3 zebras, 2 monkeys, and 15 penguins. And then it says near the entrance they found 1 zebra, 5 monkeys, and 3 penguins. So what we're trying to do is we're trying to figure out how many of each animal total there are in the zoo. Now, this might seem kind of obvious to you. You're probably saying, well, there's 3 zebras and 1 zebra, which means there's a total of 4 zebras. So notice that we combined things together that contained that same variable, that z variable. We had 3 zebras and 2 zebras, and they combined it together to be 4 zebras. I then noticed that I also lost some monkeys throughout the zoo. So here I had 2 monkeys and 5 monkeys. So I can see that here, 2 monkeys and 5 monkeys for a total of 7 monkeys. And then from here, I also noticed that I have 3 penguins and 15 penguins for a total of 18 penguins. So hopefully you're noticing here that I'm combining items together that have the exact same variable attached to them. And when we're combining like terms, that is exactly what we do. We combine things together that have the exact same variable part in those terms. So that's what we're going to practice on the next couple of slides, is how we combined those like terms together. So let's take some practice here. So this doesn't have the word example to it, but we can see that we have coefficients and variables within our problem. So we're going to start here with problem number 1, and as we combined our like terms, I'm going to suggest that we always go through and rewrite our negatives as keep, change problems. So we change those from subtraction into plus and negative if they are there. So what we're going to do is I'm going to use an underline method to help me. But what I like to do is I start with the first term here. I notice that the first term of 2w has a variable part of just w. So what I'm going to do is I'm going to look throughout the entire expression, and I'm going to say, well, I see w and I see w. So I see 2 terms that contain a w, 2 and 4. And since they have identical variable parts, I can combine them together to be 2 plus 4 is 6w. And then I move on and I look at the next term that hasn't been accounted for yet, and I see 6e. So I'm going to underline this twice to note that I'm dealing with a different variable here. And I have 6e, and I'm looking for other terms that also contain an e. So here I notice that we have a negative 2e. Well, 6 and negative 2 become 4, so I have 4e. Now, because w and e are 2 different variables, they cannot be combined further. They are not alike. So we stop, and this is as simple as we can make our expression. So now if we move on and look at this second example here, I'm going to do the same thing. Go through and utilize keep, change, and then I'm going to look and see if I can find alike variables. So here I notice that I have 5m, negative 3m, and 2m. So I have 3 terms that contain an m. So I can combine them all together. We start off with 5 plus negative 3. That gives me 2m. And then the 2m plus 2m gives me a total of 4m. So I've accounted for all 3 of my m's. 5 plus negative 3 plus 2 gives me a positive 4m. Then I notice that this b value, this second variable, is all by itself, and there's nothing to combine it with. So we add it together with the 4m to be 4m plus 3b, and because m and b are different variables, we do not combine them together further. And last but not least here, I'm going to go through in this one and utilize keep, change. I then start with my first variable of p and combined it with all of the other p's. 15 and negative 3 together give us 12p for a total. And then I notice that my next variable is an m. Well, there aren't any more m's, so it just stays 6m. I then notice my 7L here also is the only of its kind, so I write plus 7L, and because P, M, and L are all different variables, they cannot be combined together, so we stop there with our simplified expression. So where like term starts to get tricky is when we have similar but not quite identical variable parts inside of our expression. So here you'll notice that you'll only see the variable of x, but what you're hopefully noticing is this one is an x, this is an x squared, this is an x, and this is an x squared. So I've got x's and x squareds, and it's a little difficult to figure out what to do with those. So what we're going to do is we're going to reflect back on our definition of like terms from our previous lessons. And remember, like terms is talking about an identical or the same variable part. So we're looking for an exact same variable part. So x and x squared are different. So you might want to make a note of that. X and x squared are different. So we're going to solve this just like we did the other ones, but we're not going to combine anything unless they have identical variable parts. So to start, I'm going to go through and utilize keep, change, change. And then I'm going to start looking for those identical variable parts. So I start off with 6x here, and I'm going to look through and look for something with a variable part of exactly x. And if I look through, I notice I have a 5x here. Those are identical variable parts. It's just an x with no exponent. So those combined together, 6 plus 5 gives me 11x. And then I notice my next variable part is this x squared. And what I notice here is that I have a negative 4x squared and a negative 3x squared. So those can combine together to be a plus negative 7x squared, or you can write minus 7x squared, whatever you would like. Then I notice the last thing I have left are these two constant values. Constant values have identical variable parts because they do not have a variable part, and those combine together, 8 and negative 12, to be a negative 4. So you can either write your answer with the plus negatives or 11x minus 7x squared minus 4. I'll take either answer, but the biggest thing to note here is we only combined terms together if they have identical variable parts. If they're not identical, even down to the exponent on the variable, you cannot combine them together. So let's try a few more of these more difficult ones together. So looking at problem number 1 here, I'm going to go through and change all of these using keep, change, change. And then I'm going to go through one variable at a time and combine items together that have the same variable part. So let's start with 5y and negative 4y. Those are the only terms that contain a y. And 5 and negative 4 come together to be 1y. So then I'm going to look at the second variable that I see, which is x. So I have negative 6x and 8x. And those combined together, negative 6 plus 8 is a positive 2x. And then I look at the next variable part. Notice that x squared and x do not combine together because they are different variable parts. So here I have 3x squared and 2x squareds for a total of 5x squareds. And because these do not have any variable parts in common anymore, you have to stop here because they cannot be combined together any further. Then if we take a look at the second example here, again we're going to go through and utilize keep, change, change. And then from here, we're going to start with the first variable type that we see, which is a b squared. Now note here, I also have a b cubed, which maybe looks similar to you, to the b squareds. But keep in mind, identical variable parts means they need to be exactly identical. So this cubed cannot be combined with the squareds. You can only combine b squareds with b squareds. So if I do 10b squared plus negative 7b squared, I end up with 3b squared. And then I have 5b and 6b, which combine together to be 11b. And then I have just that negative 10b cubed left. So I'm going to add that in as a negative 10b cubed, or you can write it in a subtraction. So I would take either version of this. And something else to keep in mind is that the order in which you write these terms does not matter as long as the negative in this case is attached to the negative 10b cubed.